You know, a lot of people probably think AI just exploded onto the scene in the last couple of years. But the truth is, artificial intelligence has a history stretching back almost 70 years. It's been an incredible journey, and honestly, the story of AI's development is really a story about some of humanity's brightest minds. These brilliant individuals, these shining stars, are why AI has finally reached this incredible point of breakthroughs. So, if we had to pick 10 people who truly shaped AI history, who would they be? Let's dive right in and explore the first few.
Absolutely. It's a fascinating story. And if we're talking about foundational figures, we have to start with Alan Turing. Born in London in 1912, Turing is widely celebrated as one of the founding fathers of both computer science and artificial intelligence. Back in 1936, when he was just 24, Turing published a groundbreaking paper called On Computable Numbers with an Application to the Entscheidendes Problem. It was, to put it mildly, revolutionary. While Gödel's incompleteness theorems revealed the limitations of mathematical logic itself, Turing's paper clearly mapped out the boundaries of what algorithms could actually achieve. He showed us this astonishing truth: algorithms can't solve every problem. Think about famous examples like the halting problem, Kolmogorov complexity, or even the perfect detection of computer viruses. These are all problems that algorithms just can't fully crack.
That's wild to think about. So he wasn't just showing what was possible, but also what wasn't? And how did that lead to the Turing machine?
Exactly. In the process of tackling these decidability problems, Turing ingeniously proposed a truly epic-making concept, the Turing machine. This isn't a physical machine, but an abstract, ideal computational device. In theory, it can simulate any finite step-by-step computational process. If a task can be computed, then a Turing machine can perform it. This fundamental idea became the bedrock of computer science. All the computers and smartphones we use today are practical manifestations of this very concept. And get this, even the human brain hasn't transcended the theoretical framework of the Turing machine. If you accept modern brain science and believe there are no supernatural phenomena in the brain, then consciousness and emotions are simply processes of physical computation. Our brains have about 10 to the power of 14 neurosynapses, processing information through electrochemical signals and changes in synaptic weights, achieving millisecond-level complex calculations. At its core, it still falls within the Turing machine's scope. This means, theoretically, with enough computational resources, AI could replicate all functions of the human brain, including emotions and self-awareness.
That's mind-blowing. So his impact wasn't just theoretical, right? He played a crucial role during World War II as well, if I recall.
He absolutely did. In September 1939, when World War II broke out, Turing was quickly called to a different kind of battlefield, the British government's code-breaking team. Their mission was to crack the German Enigma code. Turing rapidly became a central figure in the team. For instance, the Army's three-rotor version of the Enigma machine had over 10 to the power of 23 possible code combinations. The Germans regularly changed the rotor order, initial positions, and plugboard settings, making it incredibly difficult to decipher. But the bomb decryption machine, led by Turing and his team, could decrypt around 39,000 German encrypted messages a month, with a peak of 84,000. This basically gave the Allies X-ray vision into German operations. Historians estimate that Turing and his team's code-breaking work shortened World War II by at least 2 years. It's like hackers today can cheat in games, but Turing literally cheated in World War II.
That's an amazing way to put it. And then, after the war, he gave us the Turing test, right?
Yes, in 1950, Turing published another monumental paper, Computing Machinery and Intelligence, which introduced the famous Turing test. Simply put, the Turing test involves a human having text-based conversations simultaneously with a machine and another human. The participants can't see each other. If, after a period of conversation, the human can't tell which is the human and which is the machine, then we can consider that machine to possess human-level intelligence. Today, AI systems like ChatGPT or Midjourney, to some extent, have already crossed the threshold Turing set. But I personally believe the result of passing the Turing test isn't the most important part. The true genius of the Turing test lies in how it bypasses the philosophical debate about intelligence itself. If we directly ask, can machines think or do machines have consciousness, those questions can lead to endless philosophical arguments. But Turing reframed it, can a machine imitate a human in conversation? That's a much more concrete question. Turing's message was that as long as AI behaves intelligently enough and appears conscious enough to the point where humans can't distinguish its authenticity, then that's sufficient. There's no need to agonize over whether it genuinely possesses the capacity for thought or consciousness.
That's such a pragmatic approach. But his story also has a deeply tragic side, doesn't it?
Unfortunately, yes. Given Turing's brilliant achievements in war and science, he should have been celebrated as a national hero, someone who continued to lead humanity into the intelligent age. But reality was harsh. Turing was homosexual, and while today that's not an issue, in 1950s Britain it was a serious crime. Though his sexuality was an open secret within his Cambridge University circle, he honestly admitted his relationship with another man when reporting a house theft. This was effectively walking straight into a trap. The police arrested him on charges of gross indecency. Facing the accusation, Turing chose to be completely open and unrepentant. He was ultimately sentenced to chemical castration, a treatment that caused severe side effects, including weight gain. Even more devastating, this criminal conviction led the British intelligence agencies to label him a national security risk. He, who had been a core hero in Britain's Cold War, was now completely excluded from national security projects.
That's just heartbreaking. What a terrible injustice.
Indeed. On the night of June 7, 1954, Turing ended his life at his home in Manchester at just 42 years old. The computer age hadn't even truly arrived. When Turing died, the public was largely unaware of his immense contributions to the war and science. His ideas were simply too far ahead of his time. In that barren era, he had already foreseen the path of technological development for the next 100 years. It took time for his recognition. In 1966, the ACM established the Turing Award, the most prestigious and influential award in computer science, often called the Nobel Prize of Computing. In 2009, the British government formally apologized to Turing. In 2013, Queen Elizabeth II officially granted him a royal pardon. In 2017, the UK passed Turing's Law, posthumously pardoning over 50,000 historical convictions for homosexual acts. And in 2019, his portrait began appearing on the 50-pound note, commemorating his outstanding contributions to human society. But none of this can change the fact of Turing's tragically early death. Every time I see these geniuses fall too soon, I can't help but wonder what heights they could have pushed humanity to if they had just been given a few more years. Turing is truly one of the people I admire most. If I could, I would lend him my life without a moment's hesitation.
That's incredibly poignant. What a legacy, both brilliant and tragic. All right, let's move on to the next two pivotal figures in AI history. Who are we talking about now?
Next up, we have John McCarthy and Marvin Minsky. If we trace the very origins of AI, we can pinpoint it almost exactly to 1927. Specifically within a narrow 300-kilometer radius in the eastern United States. Because in that year, two babies were born, marking their birthplaces in Boston and New York, respectively. John McCarthy was born in Boston. Stanford University's assessment of him is that he coined the term artificial intelligence and proceeded to define the field for the next 50 years. Marvin Minsky was born in New York. He established the early theoretical framework for neural networks and AI, and he was a key founder of the Society of Mind Theory.
So two giants born in the same year, shaping the same field. Let's start with McCarthy then. What were his major contributions?
John McCarthy's contributions to AI are enormous. For example, he invented the Lisp language, which is the second oldest high-level programming language in history. To this day, it remains a crucial tool in AI research. Then there's his pioneering work on time-sharing systems. In the late 1950s, computers were incredibly expensive and scarce resources. Each computer could only be used by one user at a time. McCarthy envisioned a system where a computer could rapidly switch between multiple users, allowing many people to share the same machine. This would solve the problem of scarce computing resources. So, he proposed changing the computing model from batch processing to time sharing. In 1961, McCarthy launched the world's first time-sharing system at MIT. This concept profoundly influenced all subsequent modern computer systems and network environments, and can even be seen as the precursor to modern cloud computing. He also came up with the alpha-beta search algorithm, which is still widely used in AI search today. And he introduced the concept of garbage collection, where programming languages can automatically manage and reclaim memory without programmers having to do it manually. This mechanism was later adopted by widely used modern languages like Java and Python.